Hi, this is Jim Apger with SilverTail Systems. Today's presentation is going to cover the integration talking points between SilverTail and F5. This slide deck is going to do a couple quick things here before we actually jump into the live demos. First, we're going to set the stage, give you some high-level details behind a couple of the attack scenarios that we're going to walk through. We'll give you some architectural overview talking points regarding that integration. We'll talk about, as we dive into the attack scenarios, some of the solution specifics, and then we'll expose some of the technical details for those that are interested in what's happening behind the scenes. The first live attack demo that we're going to walk through is just going to be standard DDoS. DDoS is interesting. It's somewhat of a commoditized, crowded space in the sense that we have companies like Arbor and Mazu, Landco, Prolexic, even companies like F5, that work in that space. Typically, they can be pretty expensive, and they generally cover things that happen pre-login or pre-authentication. It gets really interesting when we look at what happens after that authentication. Generally, there's not a lot of coverage in that space, and what we're proposing is that when we look at integration points between companies like SilverTail and F5, we now have coverage for things that happen post-authentication or after login. Second demo that we're going to walk through is going to be kind of a malware demo where we have an end user logging into a bank account, and the challenge is always with all of these clicks and all of these user transactions happening up there in blue, gray, light blue colors. The question is always, how do we figure out which of those clicks is anomalous? How do we identify those three red dots there representing something that shouldn't be happening, fraudster or criminal type activity? So with this quick demo, we're going to expose what happens when SilverTail actually detects a complicated attack, in this case a man-in-the-middle attack, and then how do we operationalize or generate some sort of action to stop that from happening? And that's where the F5 integration gets pretty interesting. So the big question, how do we operationalize after we actually detect? So the detection of general DDoS stuff can be somewhat interesting, can be somewhat easy considering all of the tools that are out there. So what do we do once we actually detect those? I'll show you what we're going to do in terms of reaching out into the F5 and instantiating a block based on a relatively straightforward DDoS type of attack. The second one is going to be, I'll show you how we actually detect a complex attack like a man-in-the-middle attack, which is pretty interesting. And then more importantly, what can we do with those actionable desires once we get that out there? So I'll show you how we can actually block in real time, in this case, block the IP for the DDoS type of attack, which is pretty cool. How do we actually block the user transaction, which is a little bit cooler? And then, food for thought, we can do some pretty cool things like when we detect these complex attacks, we can potentially redirect those end users to support portals to say, hey, there's something wrong with the account. I'm not going to let that wire transfer happen, but you need to call support. We can also generate a second form of authentication to kind of trip up the malware. We can do all of this based on not just IP and usernames. We can also do things like, from a fraud-specific scenario, a little more complicated scenarios get played out when we look at things like device IDs within that HTTP stream. So how do we actually get it actionable? And this is where we're going to lean on third-party solutions, generally via APIs. In this case, we're going to instantiate some SOAP calls into F5 to get things done. So, what are the options? So today we can work with firewall APIs. Generally, we tend to have solutions that are limited by IP addressing. Some of the more interesting next-gen type players may offer a little more than that. We can interact with the customer sites or the customer code, which tends to get a little more complicated and time-consuming. We can interact with customer site auth systems, if they've got the wherewithal and the temperament to kind of work down that road. In terms of the most flexible solutions out there, generally, everybody's going to have a load balancer. In this case, with F5, it's really quick to actually just instantiate a block within that F5 device, and typically in less than a quarter of a second. So how does this stuff get glued together? Generally speaking, F5 is going to sit between the end users and the servers themselves. SilverTail is going to sit somewhere in that path out of band, such that we don't actually need to be placed in line, so it's non-disruptive to the customer site. We just need a copy of that traffic, so we can sit behind the F5 device on a network switch span port. Hopefully it's in the clear. If not, we just need copies of private keys. We can also lean on F5 to have F5 give us a span port containing that same data. The point being is that we're out of band, so we're not going to actually stop anything from happening inline, we're going to lean on companies like F5 to actually perform that block. So typically what's going to happen from a business logic abuse scenario case, end users may have malware, end users may be just malicious, and they're beating up on the business logic behind the scenes, right through the F5 device, right through the firewall. So nobody's going to see that happening. Most companies don't know that that stuff is happening. So when SilverTail sees that happening on that span port, SilverTail is going to reach right out to the F5 device, tell F5 to instantiate a block based on the IP, the user address, username, device ID, and then perform that block right there. So it can get even more complicated when we look at things like user ID and device ID. What happens if we have an end user sitting who knows where, behind a browser, and they're hiding their attacks, through internet proxies? And so we just saw this recently. A good talking point is where a particular user may be sitting behind 60 hacked proxies, and through one browser, they're conducting fraud, hidden behind those 60 IPs. From our perspective, makes no difference. We can actually instantiate blocks based on that device ID so that we don't interfere with other traffic from those other IPs. So it's a pretty clever, scalable solution. What we're doing in terms of the lab, we have a couple test boxes up top there. One's labeled customer, one's labeled criminal. We've got the big IP below that, which is going to receive the traffic on a virtual IP address and then load balance that across the two www boxes at the bottom. So when we see something interesting from a SilverTail perspective, we're going to generate a SOAP call using F5's iControl code, reach right into the big IP, generate that SOAP call, which is basically just a quick call to say, hey, block this user IP. We're going to populate, think of this as a blacklist, we're going to populate multiple data groups with either IP addresses or strings or device IDs or user IDs. And then for every single HTTP connect that goes to that virtual IP address, F5 is going to do a quick check to see if somebody's been blacklisted. So for every single HTTP connect, that happens in real time. So that's pretty cool. So in this case, customer talking SSL to the big IP may or may not be in the clear as it gets bounced behind the scenes. Criminal comes in, bounce across those web servers behind the scenes. When we detect that, we'll actually kill that session. So here we go. Let's jump into a couple quick demos. I'm going to give you a sneak peek into the malware side of the house and what the typical attack looks like before I jump into the demo. In this case, user interface. I see one particular alert that needs attention. I can look at this urgent alert. I can see that I've got user SilverGem doing something that he shouldn't be doing, and it looks like a high man-in-the-middle threat. If we're interested in looking at the details behind the scenes, we can look at what happens to that particular user string. So here's SilverGem logging in, username, password, checking my accounts, looking at some details, getting ready to pay a bill, and then something bad happens. So it's this something bad piece happening behind the scenes that's terribly interesting that not many people can actually detect. So if we look over here to the right, we're going to see that we have a change in octets. I'm going to have a change in user agent. IP address changes, proximity in terms of me and the attacker is definitely interesting. But we can see that the attacker somehow had malware installed on my computer, grabbed that malware, shipped it off somewhere else, and within the span of just 4 seconds or less than 4 seconds, is now logging into my account with the same username password, going to rifle through the details and pay their own bills using my account before I have a chance to actually pay my bills. So there's an actual payment by the malware that happens behind the scenes. And if we look at a couple of other interesting talking points, not only do we see user agent changes, IP changes, but we also see things happening very rapidly. So these malware clicks are happening very rapidly. And then we're also going to see general discrepancies in how this particular session behaves as opposed to what the population normally sees. So ignoring those details, nonetheless, we see that malware is out there. I'm going to show you how we can actually stop this particular session from taking my money and paying other people's bills with those sessions. So let's also look into what happens with detection. So great, what does a typical rule look like? In this case, a man-in-the-middle rule looks just like this. I see a user with a high man-in-the-middle threat on a scale of 0 to 100. This one's a 60, or if I'm basically saying greater than 60, generate an alert. And what I'm doing is asking it to call a Python script that I wrote. that will just basically grab the user information from the bad actor list files and then pump that into the F5 device. And let me give you a glimpse of what the DDoS alert will look like as well. Really simple, nothing fancy, just for demo purposes only. I'm saying just look at, on a per IP basis, the number of hits. If it's greater than 10 within this 1 minute period, go ahead and call a different script, block the IP, send the IP info into that script so then I can reach back into F5 and block that IP address during the DDoS attack. And I'll show you what I'm going to look for within the F5 as well. So within F5, I'm maintaining blacklists. Let me get rid of that one. That's the bad guy. Oops, I want to delete that. Update. So within this blacklist, I've got a list of strings and usernames. I've also got a blacklist up here for blocked IP addresses. Let me get rid of that one as well. That's going to be my attacker. So I've got these groups over here, think of them as blacklists, that will then get referenced by iRules. So within F5, every time somebody requests or makes an HTTP request from a particular virtual IP, I'm going to say basically if anywhere in that URI I see one of those blacklisted strings, go ahead and drop that connection and then log it. So I can tell that SilverTail forced a drop of that particular user from that IP. So that's the blocked user. And then from the blocked IP, something very similar. For every single request that comes into that VIP, if I see a match of that remote IP address in my blacklisted IP data group, go ahead and drop it and log it. If not, go ahead and send it in for normal balancing. So in this case, let's pull up that data group list again for the blocked IPs. We'll notice that 1.1.1.1 is not in there. So here's my criminal up here, and this criminal is going to launch a quick DDoS attack. And what we'll see is it's going to repetitively pull the login page, so it's simulating just a generic kind of brute force attack against a website. And we're going to see the counter scrolling up there, 5, 6, 7, 8, 9, 10. It's going to get to 25 or so. I'm looking at log files so I can actually see that the alert was triggered. And then when the block is actually instantiated, there it is. It's been blocked, so it's halted at 53. And then this is the output of the script file that I wrote, where you can actually see what's being passed into the script. There's the offending IP address. We can also see what happens when I instantiate that block with F5, and I can see that it took just under a quarter second to get that block done. So nice, quick, clean, easy example of how that works. Go back in here, do a quick refresh, and sure enough, there's my offending IP address. And so let's jump into a more interesting demo scenario where I'm going to block a user. So I don't see username equals SilverJim in there anywhere. What I do want to do though is rerun some data that's going to replay that attack behind the scenes. So again, we're looking at the parsing of that data, the replaying back of that data. And what I'm waiting for is the actual detection of that. And sure enough, there it is. In this case, SilverJim was detected, and the block took less than a quarter second. And then when we refresh the list, sure enough, username equals SilverJim is right there. So it's as easy as that. So my take is most customers are going to have F5 or another load balancer out there. Total time in terms of scripting from a customer's perspective to create those data groups, to put that iRule into place is generally going to be less than 5 minutes. Once that's there, it's just a standard script on our side that parses that data apart. Put a couple quick rules in there, and that really is it. So in terms of integration, nice, quick, and clean, especially considering that most customer mindsets around fraud typically involve things like changing code or lengthy change control cycles. So it's a pretty advantageous interesting approach to take. So Hopefully you found this interesting. The tech details are right there, and if you look at Dev Central on F5, I think we're going to start posting sample scripts and sample code up there for everybody to enjoy. So thanks much, and have a good day.